Hello, I'm Tim Jones and I'm going to talk to you about some analysis methods used to evaluate health services. This is the second talk from session 2 about types of evaluation design. Here is a list of 5 analysis methods that I will be describing during this talk. I will just be outlining the basic concepts and will provide some suggestions for further reading at the end. I'll also talk about approaches to choosing a control group. I'm going to start by talking about randomized controlled trials, or RCTs. This is probably the most well-known research method, and that is because it provides the best opportunity to demonstrate that any effects we see are due to the intervention rather than some other factor. The power of RCTs comes from the randomization of people to groups. The classic setup would be to randomize people into 2 groups. The treatment or intervention group, who receive our intervention, and the control group, who don't. You may have noticed this design recently for trials of the COVID-19 vaccines. As long as the randomization is done properly, for example, not by day of the week, and as long as the trial is run well and we have a large enough sample of people, any other factors, such as age or sex, should be similar between the groups. This is true even for factors we haven't measured or haven't even considered. When done well, we should largely be able to attribute any difference in effect between the intervention and control groups we see to the impact of the intervention, because this is the only thing that is different between the 2 groups. However, randomized controlled trials are typically expensive and complex to run. This didn't matter for something as important as COVID-19 vaccines, but often does matter for smaller scale evaluations. It's not always possible to randomize people to an intervention. For example, sometimes changes to healthcare services apply to a whole local population at once, so it's not straightforward to randomize people or, for example, GP practices to the intervention or not. Furthermore, if you're exploring the effect of something like drinking alcohol during pregnancy, it's not ethical to randomize people to drink or not drink while pregnant. In other words, RCT designs require clinical equipoise, and that's the assumption that there is no evidence that one intervention is better for either the treatment or control group. Often service evaluation is required when there is no possibility of engineering a clinical equipoise scenario. For these reasons, we need other evaluation methods that allow us to work in situations without randomization of people to groups. One of the simplest non-randomized designs is the before-after study. This is when you measure some outcome before you implement an intervention, then measure the same outcome afterwards and see if anything has changed. For example, I analysed an intervention to help signpost people with dementia to various community services designed for them. The idea was to reduce the emergency hospital admissions for people with dementia. So in this case, you could take some measurement of the emergency hospital admissions for people with dementia before the start of the intervention, and then another measurement afterwards, and see if anything has changed. If the statistical analysis showed a significant difference between the time periods, could we be confident that the difference was due to the intervention? Well, the answer here is no. There are several issues with this design. One is that if there was already a downward trend in emergency admissions for people with dementia, we might expect to see this drop in the after time period, even if our intervention had no effect. Another issue might be if something else happens around the same time as our intervention that might affect the outcome. For example, the local hospital moves some of its emergency capacity to a nearby hospital outside of our area. It's worth looking at the excellent and concise summary of these issues by Steve Goodacre for further evidence on why we should avoid relying on before and after analyses. Fortunately, there are other evaluation designs that can deal with some of these issues, and I'll describe these now. One way to check for any background trend before we implement our intervention would be to take several measurements before and after the intervention. Here, the darker points are what we would see if we took a single time point before and after, whilst the additional lighter points allow us to see the trend. If we only looked at the darker points, we might conclude our intervention had an effect, whilst if we check the overall trend, we might conclude that it did not. This graph demonstrates some natural variation in our measured outcome. This is related to the concept of regression to the mean. There is some natural variation that will tend to move up and down around the mean trend. That means if we only look at the 1 month before and after data points, the darker blue points, we might assume there is an effect of the intervention, when this is actually just some natural variation in our outcome. This is the point of an interrupted time series design, which measures the outcome over several time points before and after an intervention. By including several time points, we can check for any trend before the intervention and for natural variation over time. We can look for any immediate jump up or down in the outcome after our intervention and for any change in the slope. Here we see a change in the trend after the intervention. However, there is still the potential problem that something else might have happened at a similar time to our intervention that affected our outcome, perhaps a pandemic. Going back to our before-after study, here we see that a particularly bad flu season occurred at the same time as our intervention, affecting the hospital admissions. One way to deal with this is to compare our intervention group to a control group that didn't receive the intervention. This is like the control group in the randomized controlled trial, but often with healthcare interventions, there is no randomization to the groups. We have to select a control group where the intervention did not occur. The control group now accounts for any other broader changes that happened at the same time as our intervention. To some extent, it also controls for any background trends in our outcome. This is on the assumption that background trends are similar for the two groups, and any impact of other events, such as a bad flu season, are also similar for the two groups. This is sometimes called the difference in differences design. This is because we look at the difference between the before and after measurements in the intervention group and compare this to the difference between the before and after measurements in the control group. This is quite a popular design because it's still fairly simple and to some extent controls for background trends and other events at the same time as our intervention. The national evaluation of the introduction of the payment by results national tariff funding mechanism in England provides an interesting example of the use of a controlled before and after analysis. Here, first wave hospital foundation trusts in England piloted the introduction of national tariff prices in 2004-05, which replaced local negotiation of the price of most hospital activity. The change to national prices incentivised more day case activity because now hospitals would not be paid more for patients who were admitted to hospital overnight, as long as they could typically be treated as a day case at lower cost. The change in day case rate for foundation trusts between 2003-04 and 2005-06, pre and post change in funding mechanism, was compared to that for hospitals in Scotland, which did not change their funding arrangements. The results here show that the difference in increase in the percentage of day cases was found to be 1.5 percentage points in the final analysis in favour of the English Foundation Trusts. And this was viewed as evidence that the new national tariff mechanism had generated an efficiency gain, greater use of less costly treatment practices. Finally, we have a controlled interrupted time series design. This combines the advantages of a controlled before and after design and the interrupted time series design. It allows us to compare the trends before in the control and intervention groups and see if any changes in trend after the intervention are different between the groups. Finally, when not randomizing people to groups, how do we choose our control group? Obviously, it has to be a group who are not receiving the intervention. Ideally, they would have similar characteristics to the intervention group. This is not as vital for interrupted time series designs, where the trend before the intervention acts as a control for the trend after the intervention in each group, but even then it is still desirable. For interrupted time series designs, it's important that both groups experience any non-intervention events around the time of the intervention. In the Bernal article, they produce a nice table of potential control groups, which I've tried to summarise here, but it's worth checking the extra detail in the article. Sometimes people will create pseudo-populations by having multiple control groups and weighting them differently so they end up with very similar characteristics to the intervention group. Something similar can be done with propensity score weighting, but this goes beyond the scope of this course. In summary, randomized controlled trials are usually the best design to understand the impact of an intervention on outcomes. However, RCTs are often not possible or not appropriate, and in this case there are other analytical methods that can be used. The addition of an appropriate control group strengthens analysis designs, and also our confidence in attributing changes in outcomes to the intervention. That concludes the second talk from session 2 about types of evaluation design. Here are some references which I hope will be useful. Hugh is now going to finish this session by talking about a form of time series analysis known as statistical process control or control charts, which is particularly associated with evaluating quality improvement.